Yes, Lord Vader.
Thank you. So,
You didn't know what to say on that one.
I got nothing. So last day on 6.1. So we've already learned all the rules you're going to use. Okay, there's really no new rules like for adding exponents and multiplying exponents. The only new rule we got to look at is when it's a negative. Okay, so far we've been working with positive exponents. In order to figure out how negative exponents work, I want to kind of look at a pattern.
And guys, you don't have to worry about writing this. Mr. Hager's just showing you the pattern right now.
Is this on their guided notes, Mr. Roy?
No. Isn't that just a block?
No, they're gonna write it in. They're gonna write it in when we go over the rule. They can write it in.
Gotcha. All right, so let's start with 2 cubed. What's 2 cubed? And what would that be? 8. How about 2 squared? 4. And we're going to stop with 2 to the first. 2. What did we do to get from 8 to 4? Yeah, let's think of it as dividing by 2. So to get from here to here, we divided by 2. How about from here to here? Divided by 2. So what do you think we're going to do to get to the next one? So,
That'd be 0, then -2, then
so what's 2 divided by 2? 1. Okay, this thing that we just came up with, you're going to write that down in a little bit, but it doesn't just work for 2 to the 0, it works for anything to the 0. 3 to the 0, 5 to the 0, anything to the 0 power.
Even for variables, guys. Even for letters.
Yep, is always going to be 1. Now, let's go back one more step. How are we going to get to that step? We're going to divide by 2 again. What's 1 divided by 2?
-1. Wait, no.
No, when you divide a positive by a positive, it's still positive. What's 1 divided by 2? 1/2. And then if we went back one more step, what's half of that? 1/4. So what kind of numbers do you notice we're getting with negative exponents? Fractions. Okay, that's what negative exponents are, fractions. In most problems, what we try to do is get rid of the negative exponent before we start doing anything. Okay, that's kind of the goal. Get rid of that negative exponent. And this is what you're going to write on your reference sheet. Any number except 0. Okay, you can't do 0 to the 0. If you try to do it, it doesn't work. But any number except 0 to the 0 power is 1.
So guys, what's underlined up there, any non-zero number raised to the 0 power is 1. That's what you want to write on your guided notes.
If you try doing 0 to the 0 on your calculator, it's going to be undefined. And if your calculator breaks or overheats or the screen cracks, I warned you to not type that in. So I wouldn't type that in.
I want to do it.
Don't do it. Do it on someone else's calculator.
Hey guys, there's a little line on there that says, a little bit that says EX. All right, for the example, write what Mr. Hager put a box around. 2 to the 0 equals 1. And we have an example that you can actually see. And also the description of the reading.
Okay, so what's kind of nice about this rule is if you had a bunch of stuff and all of that was to the 0 power, it all just simplifies to 1. It doesn't matter how complicated this is. If you have a bunch of stuff to the 0 power, it all just turns into 1. Okay, I think we look at another example like that.
Oh, never mind. I feel stupid.
Okay, does everybody have that? You good? Okay, let's start with this. Okay, can I do anything to simplify the number 4? Okay, think of it as 2 separate things.
No.
No.
So it's 4 to the -5.
What about x to the 0? What did we just say anything to the 0 power is? 1. So x to the 0 turns into 1. Now do this out. What's 4 times 1? 4. That's the answer. That's it. Okay, so 4 times x to the 0 is 4.
Why did the x disappear?
Because anything to the 0 power, this whole thing turns into a 1.
Okay.
Anything to the 0 power except this, which I warned you not to type in on your calculator.
I wanted
So don't do it. Anything to the 0 power is 1. How about this one? 5m, all of that to the 0 power. 1. We have a whole thing raised to the 0 power. You don't have to do anything else. If it's to the 0, it's 1.
Guys, what's underlined there where it says each constant number and variable is treated separately, you don't have to write that.
Okay, what if it was something like that? What if it wasn't a 0?
You have to do 2 equal.
What would be your first step?
Simplify 2 to each of them.
Put the ones,
Yeah.
and then what would you do?
Then do 2.
Multiply them. So what's 1 times 2? And then 1 times 2 again? Another 2? And what's 5 to the 2nd power? 25.
It's not 5 times 2, it's 5 times 5.
So when you have one that's not a 0, that's what we did yesterday. We do it exactly the way we did yesterday. If it is a 0, you just put 1. You don't have to do any of these steps out if it's to the 0 power. Just put 1. I think we got one more with zeros. Okay, this is what I just explained to you, but if it's 0, do what I just told you. Just copy the example. X times y, all of that is to the 0 power. What's the answer? 1. Now, what if it was like this? X to the 0 power times y. You could put a line there and separate it if you want.
1y.
That's 1. X to the 0 is 1 times y. So in that case, yeah, it's just y. So you got to be careful. Does the 0 apply to the whole thing, or is it just, in this case, just the x? Does everyone see the difference between those two?
Yeah, and that parentheses around it, guys, it has a 0 on the outside, and Mr. Hager just said, whatever's on the inside becomes 1. I don't care how much stuff is in there. I don't care, like he showed you earlier, if it's like a division problem. If the whole thing has parentheses around it with a 0 on the outside, your answer's gonna be 1. I don't care what's inside there.
Okay, so any questions on 1A, B, or C?
No.
Okay, those are the pretty basic ones. This step that we just did is going to be part of a bigger problem.
Hey guys, what if Mr. Hager, just go back for a second. Guys, what if we had something like that? I'm just gonna make this up. What if we had like negative 0.3 to the 0 power? Or if we had something like that, negative 0.3 to the 0 power? 1. It doesn't matter what the base is. It doesn't matter. It could be anything you want. It could be negative 1,365,000.
Mr. Roy, is that negative inside or outside the parentheses?
It's inside.
Okay.
Yeah. It's
Yeah,
inside.
because if you had this
Yeah.
versus this, 2 different problems.
Yeah, all it's gonna, like Mr. Hager's showing you guys here is, all it's gonna happen is, this negative's outside, so all we're gonna do is, when we get this, we're gonna get 1, but we're not done. We almost gotta like, just slide that negative sign over to get negative 1, because it's on the outside, so we're just gonna bring it down, because it's not inside the parentheses. So, I'm just trying to show you guys that even if it's decimals, it doesn't matter. If it has, like Mr. Hager showed you, if it had like division, 2 to the 3rd, y to the 5th over 10x3. If it's to the 0 power, the whole thing is going to be 1. All right? But if to the 0 power is just on the top, all right, then you just do, the top will become 1, the bottom will stay as is. All right? So it works for anything, it doesn't matter.
All right, so now the idea with negative exponents, okay? We don't want to have to work with negative exponents. So the first thing we're going to do in any problem, if we have a negative exponent, we're going to get rid of it. How do you get rid of it? you have to move it. Okay, you have to move the number with the exponent attached. Where do you move it? Well, we have a fraction, right? A fraction has a top, has a bottom. If we have a negative exponent in the top, we're going to put it in the bottom to make it positive. If we have a negative exponent in the bottom, we're going to put it in the top.
So guys, you have on your note sheet already written, if we have a base with a negative exponent, you're just going to copy everything after the comma. So move the base with the exponent to the opposite place in the fraction to make the exponent positive. So just going to move to the opposite location. Happens, David.
All right, so these directions here assume that you have a fraction. What if you had something like that?
You put it over 1.
It's supposed to be a -2. I don't have a top, I don't have a bottom, I just have a single term. So how could you make it a fraction?
Everything right, always.
You could always put it over 1. And now you have a fraction. So if we were going to fix this one, x is the base, -2 is the exponent. That x and -2 are stuck together. Okay, we can't separate them. So this whole thing that I circled, where is it in the fraction? Is it in the top or the bottom? It's in the top. So where would we move it?
The denominator.
We'd move it to the denominator. Anything else that's in the denominator just stays right where it is. But that x to the -2 is going to join it. Now, when you don't have anything left in the top, because in this case there's nothing else, we're moving everything to the bottom, you've got to leave something in the top. So whenever you don't have anything, you just put a 1, okay, to hold the place. And now, in the bottom, you have a 1 times that x to the -2 is going to move down. But what's going to happen to the -2 when it crosses that fraction bar? Yeah. So whenever something crosses that fraction bar, all of a sudden, the exponent becomes positive. And that's it. What's 1 times x squared? X squared. So what we started with and what I just circled, exactly the same thing. Okay, and we're gonna try a couple more of those. But all the rules that you learned already still
You
apply.
guys, you have it, yeah, we just basically, you just kind of like summarize with the second bullet that was there, you just kind of just summarize that right there.
Yeah,
Okay.
I thought that was easy.
Yeah. Hey guys, you're gonna see, the examples that we do, you're gonna see that. And then, like the last bullet, the second bullet that's on your notes, don't worry about it. If you copy down what Mr. Hager wrote, moving that stuff around, that's fine. And then you have written on your notes as the third bullet, all the rules we learned over the last 2 days still apply. So you have that.
Okay, so directions say simplify, use positive exponents. Okay, there's nothing wrong with negative exponents. If you're doing a problem and the directions say to do the problem and you end up with a negative exponent for an answer, that's fine. Unless the directions specifically tell you not to do that. Okay, if they tell you not to, then you need to fix it. All right, 5 to the -1. Okay, what would be the first thing I would do here?
Make it a fraction.
make it a fraction. You always have to make it a fraction. If it's not a fraction, make it a
Hey
fraction.
guys, as soon as you see, you know what, we might get some stuff later where there's a whole bunch of stuff. All right, this is simple, there's only one term. We're going to get into one, might get into other stuff where there's more than one term. As soon as you see one negative exponent, put the whole thing over one. Makes it easier to move it around.
All right, what's going to move here? Tell, 5 to the negative 1. This whole thing is stuck together. Where is it going to move to? Bottom. What's that going to leave me with in the top? Just a 1. There's nothing there, so you got to put something. And what would be in the bottom now? 1 times 5 to the 1. Anytime that crosses that fraction bar, the negative on the exponent goes away. Okay? What's 5 to the first power? 5 times 1. 5. That's the answer. So 5 to the negative 1 is 1/5. And watch what happens if I type that in. There's 5 to the negative 1. Okay? 0.2. There's 1/5. What do you notice? How do they compare? Yeah? They're the same. That means I did it right. I started and ended with exactly the same thing. Except I started with a negative exponent, I ended without one. So that is correct. Okay, let's try this one. Okay, there's 2 ways you could do this one. We can deal with the negative exponent right away, or we can deal with it later. How do you want to do it? Deal with it, get rid of it right away? Okay, so we're going to get rid of it right away. What do we have to do to get rid of it right away? First thing, make it a fraction. If it's not, you might have a problem where it already is. Okay, what needs to move here? The 3 to the negative 8. How come we didn't move the 3 to the 5th? Because the exponent is already positive. Does anybody know what would happen if you moved an exponent that was already positive to the bottom? It would turn into negative. Okay? So we don't want to do that. Okay, when I move 3 to the negative 8, what's left in the top? 3 to the 5th. So do I need to put a 1 there this time? No, because there's something left there. I only need to put a 1 if there's nothing there. What's going to be in the bottom? Yep, 1 times 3 to the 8th, which is really just 3 to the 8th. Now, this is a problem like we had yesterday. We don't have any negative exponents left. What do? When we have same base, one's in the top, one's in the bottom, what do you do with the 2 exponents? Subtract them how? Eight larger minus smaller. Yep. What's 8 minus 5? 3. So we're going to be left with 3 to the 3rd. Top or bottom? Bottom. Why? Because that's where the bigger number was. Now you've got to put something in the top. You can't just leave it empty. 1. And there's our answer. Okay. If they asked you on the test to do out 3 to the 3rd, does anyone have a question on how you type 3 to the 3rd into your calculator? If you had to, you could just do 3 times 3 times 3 and hit equals. Okay. Anybody know what it would come out to? It would be 1 over 27. Yep. But the directions just said to use positive exponents, so that's where I stopped. Okay. Let's see, do we have another one for example 2? Oh yeah, 2 more. 2 more and then you're up.
Yes, Lord, man.
So, three terms here, right? 3 factors. A, b to the negative 7th, b to the negative 3rd. Is there anything here that is okay? We can leave it. The A. It doesn't have an exponent, but what is it invisible? It's a to the first. So the a is fine. That's an a. So everything else has to move. This and this both go down to the bottom.
But did you want to combine them?
And remember, we should always put it over 1. I forgot to do that. Put it over 1 first. So that's when I asked the question, do you want to deal with the negative now or later? You could combine them and then move it, or you can move it and then combine them. You can do it in either order. But for the way we did it, I think we should move it and get rid of the negative first. So then we don't even have to worry about doing any kind of arithmetic with negative numbers. Okay, what's going to be left in the top? A. What's going to be in the bottom? First thing. B to the 7th times what? B to the 3rd. And now in the top, there's nothing you can do. It's just an A, there's nothing to combine it with. How about in the bottom? Multiplying same base. What do you do with your exponents? B to the 10th. Now because this one doesn't involve numbers, there's nothing else you could do. Okay, 3 to the 3rd, you could type that in on your calculator. B to the 10th, you can't. It's letters. So you stop there. Any questions on 2C? Okay, last one for example 2. All right, this time we have how many different things in the top? More than 2. 4. X to the negative 5th, y squared. X to the negative 4th, y to the negative 2. That's 4 different things. We're going to put them all over 1. Okay, somebody tell me one thing that has to move. Can't stay where it is. Negative x to the... All right, what else has to move?
X to the negative 4.
X to the negative 4. Y to the negative 2. Now, when you move something across a fraction bar, what? Can somebody explain what happens again? Yeah?
The exponent becomes a positive, but the base stays the same.
The base stays the same. The only thing that can become positive is the exponent. Nothing else. So if something else has a negative, that stays. Only negatives with exponents disappear. So, what's going to be left in the top? What's the only thing we didn't move? Yep, y to the 2nd. That's in the top. When you move this first one to the bottom, what is it going to change to? Perfect. Negative x to the 5th. Okay? That negative doesn't go away on the x. It's not part of the exponent. Only negatives in the exponent go away. We don't have to worry about that anywhere else. Okay, so we have negative x to the 5th. What else? X to the 4th. Yep. And what else? Y to the 2nd. Okay, do I have any like terms that I can combine at the bottom? Okay, yep, we could do that first, actually. So the y's cancel out. How come they cancel? Same exponent. 2, 2. They're gone. So there's nothing in the top. You've got to put something there. 1. Negative x to the 5th times x to the 4th. Negative x to the 9th. And that's your answer. Now, what if they wrote this? Negative 1 over x to the 9th. How does that compare to what I just circled? The negatives at the top versus the bottom. Does that make a difference? No. Right? If you want to write the number negative 1/2, you could put it like this. You could put it like that. That's the same number.
We can put like in between the both, right, Mr. Hager?
Yep, doesn't matter where you put the negative. So if you get this, and a multiple choice question has this, they're the same thing. No difference. Okay, any question on why we got x to the 9th? Okay, because same base, you add exponents.
So guys, the base is really the same, and we could put an imaginary 1 there, and that would make these two things separate, right? The base is still the same, x, x. All right, so guys, so yesterday, we followed some steps. When we get into some problems that have a lot of different things going on, all right, we're gonna want to have a set up way, or some steps to follow, so we can kind of know where we're at. Today, we're only going to add one step. Does anybody think they know what that one step we add might be? Think about what we've just been doing. What's that one step we're going to add, you think? We've talked about it today. We just did it. Close, Antonio, close. We already did division. We didn't really, the rule we've talked about today didn't really have any real arithmetic or anything. Huh? Yeah, we're going to be changing the negatives, right? That's the new step we're going to add. All right? Step 1 is going to stay exactly the same as yesterday. Does anybody remember the first step from yesterday? And remember, same thing as yesterday. You may not have to do all these steps. A couple of the ones we did yesterday, we were only doing like step 4 and 5. And I think we did a couple that had step 3, 4, and 5. All right? But does anybody remember the first step yesterday, Nini? Power to a power. That stays the same. All right? That's going to stay the same. So power to a power, if possible. Again, we may not have to. There might be no parentheses there. And remember, just as a little visual for you guys, here's the exponent on the outside, and we're going to multiply it in to every exponent on the inside. If you need to, I think most of you guys know, but if you don't, you can put multiply if you need to. All right, you can write in multiply. So again, there's going to have to be parentheses there to do power to a power. All right, there's going to have to be a number outside the parentheses to do that. All right, now this is where we get into this is when we get into what we talked about today. Step 2 is going to be new. All right, everything else after that is going to be the same as yesterday. So here's the new thing, like we've been talking about. All right, we're going to move bases with negative exponents, all right, to the opposite place. We already talked about it in our rule. If it's in the top, move it to the bottom. If it's in the bottom, move it to the top. Make sure you take the base with it, right? The base and the exponent go. The only thing that's going to change is the exponent becomes positive. Nothing happens with the base. Very rarely when we're doing this stuff does the base ever change. The base is always going to stay. Right, that will make, when you move it from going to the top to the bottom or bottom to the top, that's what's going to make the exponent positive. And then we have step 3, 4, 5, and 6, right? And they're going to be the exact same rules that we went over yesterday, right? Like I said, the only thing that's new today is step 2. Everything else is pretty much the same, all right? So, step 3, if we have numbers, whole numbers or big numbers with exponents, all right? Here's an example right here. If we have 3 to the second power, we want to simplify that. We want to make it 9. All right? Remember, we're going to multiply the base as many times as the exponent tells us to. 3 to the second, 3 times 3. 4 to the third, 4 times 4 times 4. We're going to multiply the base as many times as the exponent tells us to. And again, we're not always going to get this, right? So we'll simplify the numbers with exponents. All right? Now, guys, Mr. Can you change this? Can you change that real quick for me? Those 2 steps. Don't write this down yet, guys. I want to change the order. Mr. Hager's going to do it for me. Make this a 5. Perfect. All right, so next thing we're going to do is we'll add exponents with the same base on the same level, if we have it. All right, things that are on the same level, that have the same base, all right, we'll keep the base and we'll add the exponents together. Again, that stuff, this is what we did on, we did that stuff on Monday. Right, when we were multiplying exponents. We were really adding the exponents together. Keep the base, add the exponents together. They have to be on the same base. All right, they have to be on the same level. Are you writing this down inside? Huh? I'd rather see you write it down. All right? Because guys, tonight on your homework, these steps are going to need to be on there. All right? Yes?
What was that?
Step 1, power to a power, Maggie. On your homework tonight, on the reference sheet, we're going to want you to write down these 6 steps. So you have, we got some space on there for you. And tonight's homework is only one side. So if you need to write them one side, right, Mr. Hager, I'm correct. If you need to write these on the back side, all right, I would do that. You don't have enough space. If you don't write these down, we're going to take points off your homework. You need to have these steps written down, right, to get full credit for your homework tomorrow. You need to write them down. All right? Number 5, we're going to subtract exponents with the same base on different levels. And then we'll put our answer where the bigger exponent was. We did that stuff yesterday. Right? We did the division of exponents yesterday. Same base, different level, subtract, put your base, right, with the exponent where the bigger answer was. All right? Remember, we're always going from the bigger number to the smaller number. Always bigger to smaller. Again, that was stuff that we did yesterday. All right, so step 5 we did yesterday. Step 4 we did yesterday. Step 4 we did on Tuesday. Step 2 we did today. And then step 1 we did on Tuesday as well. Guys, I'm just going to move on to step 6, and I'll give you guys time. Reduce the numbers if possible. If you're not sure, remember yesterday we had like the 2 little arrows. Remember, we want to see if the can the bigger number go into the smaller? Can the bigger go into the smaller? Or your other option is, can both numbers be divisible by? Can they be divided by a certain number? Those are your 2 choices. If either of those things don't work, then you can't reduce the big numbers, right? Remember, we're only reducing the whole numbers, all right? Not the exponents. We can't reduce those. We're going to reduce them doing the other steps. Here, I'm looking at big numbers only. Remember, I want to check and see if the smaller can go into the bigger, or if there's a number that goes into both. That can help me reduce them. One or the other. All right? Let me do... About that mistake. All right, so and we get the steps right here. All right. So step 1, power to a power. Do I have that? For 3a, example 3a, that's going to be on the back side of your notes, guys. 3a, do I have power to a power? How come, Liam? No parentheses, right? Okay. I'm going to look at step 2. Move bases with negative exponents to the opposite place and make exponents positive. Do I have that? Huh? Do I have that, Emma? Do I have any negative exponents? I do? Give me 1. X to the negative 4, that's 1, okay. Does anybody see any other negative exponents? And tell me the base as well. Y to the negative 5, okay. There's my 2. Good. That's all I'm doing right now. Here's my division line. I'm going to make that a little bit smaller. More steps. All right. On the top, what's the first thing I'm going to write? We're not even doing any type of arithmetic. 6, right? I couldn't do anything with it. I'll leave it. What else is going to be on the top? Antonio, what's another thing that's going to be on the top? Y to the 2, yeah, that'll stay because it was positive, then have to move it. Will there be anything else on the top? Any other bases with exponents? Huh? No? Look at what I circled, right? Remember, on step 2, so we're moving bases to make them positive, right? We want to make the exponents positive. Is there anything else there? Mr. Hager's giving you guys a little hint. Y to the negative 5. Where's that going to go? On the bottom? It's going to stay on the bottom or go on the top? It's going to go on the top, right? So we want to make the exponent positive. What am I going to write? Y to the 5th, right? When I move, that's the whole reason for moving it, right? Because I want to make the exponent positive. Good. Kyle, what's the first thing I'm going to write on the bottom? Negative 3, right? Whole number, I can't do anything with it. What else is going to be on the bottom, Kyle? X, right? I didn't need to move that, it was positive. And there's going to be one more thing on the bottom. No, that's gone now. That's all. I can cross that out if I want. That's already been moved. It'll be x to the 4th now, right? So I have my x and my x to the 4th. All right? Because I have x to the negative 4 on the top, and I'm going to move to the bottom. And if you guys want to, when you move stuff, if you want to cross it out so you know you moved it, that's fine too. If you want to circle and draw arrows to show that you're moving it, you can do that too. All right, cool. Number 3 says simplify numbers with exponents. What are my 2 whole numbers? 6 and negative 3. They have an exponent, right? What's the exponent for both? Doesn't matter, right? Every number we write to the first power. We just don't write to the first power. Right, great. I love step 3. Number 4, add exponents with the same base on the same level. Add exponents with the same base on the same level. All right, so Nini just said 5 and 2. 6, I'm going to leave it alone. All right, I have a y as a base and a y as a base. Keep the base, right? Write y. What else is going to be with the y? To the 7th power. What am I doing with the exponents? Adding them, right? They're on the same level. There's no parentheses. There's no multiplication there. Keep the base. The base is y. Add the exponents. 2 plus 5, 7. On the bottom, negative 3. There's nothing I can do with it. All right? There's no exponent. There's no exponent with it. What about the x's? X to the... Again, same rule. Keep the base. Add the exponent. Step 5. Subtract exponents with the same base on different levels. Do I have the same base on different levels? What do I have for a base on the top? Y. What do I have on the bottom? X. They're not the same. All right, great. Step 6. Reduce numbers if possible. What's my first option to reduce the numbers? I should see if I can do what? What's one way I can reduce? There's one way I can do it before I get to that. Check and see what? If the smaller can go into the bigger. So Emily, can the smaller smaller number go into the bigger number?
Yeah.
All right, how many times?
2.
2. I'm going to cross out the 6, make it a 2. I'm going to cross out the 3, right? Because we know 3 goes in that. That's it. I mean, it would end up becoming 1. You don't have to write the 1 though. All right. So on my top, what am I going to have? I could write that negative 2. What's left? Y to the 7th. And then on the bottom, I'm going to have x to the 5th. So we took this negative and just moved it to the top. The other way around works too. 2y to the 7th over negative x to the 5th. Either one is fine. Whether you have, Mr. Hager explained it. Whether you have the negative on the top or on the bottom, it doesn't matter. Don't have it in both places, because what does that mean? Negative on the top and negative on the bottom.
it's gonna become a positive, right? So we don't want it in both places because it'll become positive. So for this, either one works. Either one will work, all right? Let's look at one more together, and we got a couple for you guys you can do on your own. And you'll still have time to print out the homework. All right, this one. First step. What's the first step? As if I'm going through my checklist, what's the first step? Power to a power. Antonio, yes or no? No, why? There's no what? For a power to a power, you need what has to be in the problem? Maggie, what has to be in the problem for power to a power? Nice job, Maggie. No parentheses, right? Good. Step 2. What's the second step? Ariel, what's the second step?
Move the bases with the negative exponents
Move.
in the opposite place.
Okay. Do you see any?
Yeah, B to the -2.
Okay.
And then A to the -3.
Good. And we can just draw arrows, right? I can draw an arrow going up here. I can draw an arrow going down here. All right. So, Jordy, what's the first thing I'm going to write on the top? What's one thing on the top that's not going to move? Careful. What's the first thing? What's the first thing written in the problem? What, Jordy? Don't listen to Vanessa. Look at the top, right here, right? Look at this. What's the first thing written on the top?
4.
-4, right? That doesn't change. Nothing I can do with it. I'm just going to bring it over. Anything else going to stay on the top, Jordy? Look at the board. Don't look at your hand. There's not going to be no answer there. Look at the board. A. Keep going.
B.
A to the.
Oh, A to the power 3.
Good. No, I can't do anything with those. Now, what's coming to the top? Me? A to the -3, right? It's on the bottom. I'm going to move it to the top to make the exponent positive. Maggie, what's the first thing I'm going to write on the bottom? 10. Nice. Anything else on the bottom that doesn't need to move? B to the second power. What's coming down? B to the -2, which becomes what? B2. All right, now, same, do I have any exponents with whole numbers?
Yeah.
I do? With the big numbers. I mean, there's a 1 there and a 1 there, but it's going to reduce to the same thing when I simplify it, okay? Cool. How about same base, same level? What do I got? So I'm not doing anything with my whole numbers. I'm just leaving them right now. So same base, same level. Natalie, what's one thing I have? Same base, same level. The A. And what's it going to become? A to the power of 6. Good. Bottom. Ashley Aldana. Bottom. Same base, same level. B. And what's it going to become? Yes, you do.
Just kidding, B4.
Yeah. Told you you did. All right. Am I done? Am I done?
No.
Ms. Diaz, am I done? What do I have to try to do now?
The regular numbers.
Okay, what do you want to do with those big numbers? The whole numbers. Can't subtract them.
No, multiple.
I want to make them smaller. All right, what number am I going to divide into them? What number goes into both? 2. So I'm going to divide this by 2. I'm going to divide that by 2. So -4 divided by 2. Careful. -2. A to the 6 stays. On the bottom, 10 divided by 2. 5. B4. Here's my final answer right there. Again, one of the main differences between these two was how we reduced. The top one, all right, the smaller number went into the bigger number. For this one, we had to find the number that went into both, all right? And like KD told us, 2 goes into both. That's your final answer for that. I think we have one more example, then we're done. All right, it's only one though, and it's quick. All right? This one.
Oh,
Now, I got a negative 4. I got a negative 4. What am I going to do here? What rule? I have exponents now, so what does that mean? What do I have to do when I have exponents? Power to a power. What's the power on the outside? Negative 4. What's the power on the inside? What am I going to do? What math operation? Multiply. 3 times negative 4. What about my base? This stays as A, right? A to the what? No. Look what I wrote. 80, huh? Negative 12, right? Remember, I'm multiplying. Here, when the exponent's on the outside, with parentheses at the end, that's when you're going to multiply. That's power to a power. If there's no parentheses, all right, you'll just add the exponents if they have the same base. What's wrong with this? Huh? Has a negative what meaning? It's got a negative exponent. What can I do? Put it over 1, right? What needs to happen? Elise, what needs to happen? Yeah, so what am I going to write here, Elise? Let's make it easier. What am I going to put here? On the bottom. A12, right? Because it's negative, right? Now I need to move it to the bottom to make it positive. There's nothing on the top. What's that placeholder? 1. So it's a little bit different, guys. When we've done power to a power, we've done power to a power with a positive number on the outside. This could work the other way too, guys. If I have like b to the negative 2, and then 3 on the outside, it's still the same thing. I'm going to get b to the negative 6, put it over 1, flip them, 1 over b to the 6. So even if I have a negative on the inside, multiplied by a positive on the outside, it's the same thing. You're still going to have to put it over 1 and flip it to make that exponent positive. All right? Good with this? No. You need to write it down, Tony? Okay. So it doesn't matter. Either way, it doesn't matter. You're still going to have to move the base in the negative exponent to make the exponent positive. You're still going to have to do that. Right? So it can be, we could ask you this way on the test tomorrow, we could ask you that way. But it's the same thing. It doesn't matter. All right? So, homework, 6.1 reference sheet. I think there's 10 problems. All right? And as always, you can use it on the test tomorrow. Make sure the last question is to write the steps from today. You need to write the steps to get full credit. When Mr. Hager and I check homework tomorrow, if you don't have all the steps written down, you're not going to get full credit. All right? You guys still might want your notes of what we're going to do after this. All right? Reference sheet, it's on Google Classroom. We're probably going to give you guys some practice problems for like 10, 12 minutes. Then we're going to give you guys some time to get that printed off. If you can print it at home, that's fine too. All right? Next thing. Remember, we told you at the beginning of the week that tomorrow's test was going to be the second of the quarter. But it's going to be the third. Why is that?
Mondays count.
Mondays counts, right? It says it on there. We're counting Monday's test, those 4 problems, as an actual test grade. All right? So now you have 4 test grades instead of 3. Remember, progress reports close tomorrow. So if you didn't make up the test from last academic week, that will show up on there. If for some reason you don't finish tomorrow's test, all right, that will also show up on your progress report. It'll say 0 for test quiz not made up. All right, obviously we're not going to give you a 0 for it. You just have to find the time to get it made up. All right, and tomorrow, a lot of you guys that didn't finish the test from last academic week, I don't think there's too many of you, but if there are a couple of you, or people that didn't finish, weren't here Monday, if the people I take out finish early tomorrow, people that need to take that other one, I can review with you guys downstairs, get you caught up with that, and you can take that test tomorrow. So I don't think tomorrow's test is going to take too long. It's probably one of the short, it's 10 questions, but some of them are really, really basic and really, really quick. All right? Last thing, remember, you've got a double academic week coming up. All right? The next two, I'm sorry, should say double shop week, I'm sorry. You got a double shop week, yeah, double academic. Double shop week coming up. Shop week. Double shop coming up. All right? So your next academic day, your next academic Monday is the 22nd. That week is your next academic week is the last week of new stuff. All right? Then you'll have a shop week. Then that next week of academics in June, probably the end of that week is when we're going to have our final exam. All right?